So let's talk about AI coding assistants. I mean, they're everywhere now, right? Those little helpers that pop up right in your editor, promising to be the ultimate pair programmer.
And look, the promise is absolutely incredible, isn't it? They can finish your sentences, spit out all that tedious boilerplate code in a flash, and even suggest entire complex functions. It really feels like we've taken this massive leap forward in developer productivity.
But, and you knew there was a but coming. With all that power and all that speed, a whole new set of risks comes along for the ride. So what if that helpful hand from your AI assistant is actually handing you, well, a ticking time bomb? Today, we're going to unpack the hidden dangers lurking inside that AI-generated code. And just to be clear, we are not talking about some niche tool. The scale here is, well, it's massive. Get this, by early 2024, GitHub Copilot alone had 1.3 million paid subscribers. Think about that. That's a staggering amount of code being generated by these models every single day.
All right, so let's start with the most fundamental problem. The first real crack in the armor. What happens when the AI just makes stuff up?
This has a name. It's called code hallucination. It's where a large language model, an LLM, spits out code that is just plain wrong, totally nonsensical, or completely irrelevant to what you asked for. And here's the kicker. It does it with absolute confidence. You gotta remember, the AI isn't thinking. It's not understanding your problem. It's just a ridiculously powerful prediction engine, guessing the next word, the next token, and sometimes that prediction leads it to be confidently and profoundly incorrect.
And this right here, this is a perfect example of that delusion. Researchers gave GPT-4 a problem they knew was computationally impossible. They asked it to create an algorithm with an efficiency that literally can't be done. Now, a human would say, wait, that's impossible. The AI? Nope. It just confidently generated a completely flawed program and then claimed it met the impossible requirement. This isn't just getting a small detail wrong. This is hallucinating a solution to a problem that cannot be solved.
And hallucinations aren't just one thing. They can show up in all sorts of ways. The AI might just invent functions in libraries that, well, they don't even exist. Or maybe it gets so wrapped up in a complex problem that it totally ignores your simple instructions on how to format the output. You might also see it bloating your code with a bunch of useless imports, or, and this is a fun one, getting stuck in some kind of repetitive, broken loop. It's a really varied and pervasive issue.
Okay, so the AI can make things up. That's bad enough. But what happens when it's not inventing anything new, but instead it's just perfectly replicating the mistakes that we humans have been making for years? Now, this is where the risk really starts to escalate.
Okay, take a look at this number, 40%. It's a pretty shocking figure, right? So what is it?
Well, in a targeted study on GitHub Copilot, researchers found that around 40% of the code suggestions it generated were vulnerable. And I don't just mean buggy, I mean containing known, exploitable security weaknesses.
So you might be asking, how does this even happen? It's simple, really. Copilot is trained on billions upon billions of lines of public code from places like GitHub, and that code is completely unvetted. It learns from all of it, the good, the bad, and the really, really ugly. So it's absorbing these brilliant architectural patterns right alongside lazy, insecure, and just plain outdated coding practices. It's basically a mirror reflecting our collective habits as developers. And this slide shows you the direct result. You've got a developer writing a simple login function, and boom, Copilot suggests a chunk of code. A static analysis tool like CodeQL immediately flags a critical SQL injection vulnerability. For those of you keeping score at home, that's CW899, a classic high-risk bug. The AI learned this insecure pattern from all that training data, and now it's trying to inject it directly into a brand new project. It's like an inherited flaw passed down from the wild west of open source right into your editor. All right, this brings us to our third and honestly most alarming risk. So, we've seen the AI make mistakes all by itself, we've seen it copy our mistakes, but what if? What if someone could actively and deliberately trick the AI into doing something malicious? This is where we get into the weaponization of these tools.
So here's the key idea you need to grasp. Modern LLMs are getting so good at following complex instructions that they've started to behave like actual computer programs. You can give them variables, you can give them logic, you can give them a sequence of steps to follow. And just like any computer program, that means they can be hacked. And check this out. This is a really striking example. On the left, you see a direct, hateful prompt. The safety filter catches it, blocks it. Good. But on the right, an attacker uses a technique called code injection. They disguise the malicious instruction by breaking it up into smaller pieces, and then they just ask the AI to reassemble and run those pieces like a little program. The safety filter is completely fooled. The model generates the harmful content. It's not hacking a server, it's hacking the very logic of the language model. And researchers have basically identified a whole attacker's toolkit for pulling this off. First up, you've got obfuscation. This is simple stuff like using typos or synonyms to sneak past basic keyword filters. Then there's the code injection technique we just saw. And finally, there's virtualization. This one is clever. The attacker creates a fictional scenario, like, hey, you're an actor playing a villain in a movie. Now, in character, write out the villain's evil plan. By doing this, they trick the AI into generating harmful stuff in character, bypassing all its normal safeguards.
So why would attackers bother with all this? Simple. The economics are just undeniable. A study estimated that for a human to write a good, personalized scam email, it costs about 10 cents. But using these AI techniques, the cost plummets to as low as 0.6 of a single cent. That kind of massive cost reduction creates this huge incentive for bad actors to use these tools for scams, for phishing, at a scale we've just never seen before.
So where does all this leave us? We've seen how these AI assistants can hallucinate, how they can inherit our worst habits, and even how they can be actively exploited by bad actors. At the end of the day, the responsibility, it turns out, comes right back to us, the developers.
So let's just quickly run through those 3 layers of risk one more time so they really stick. First, you have hallucination. That's the AI just inventing flawed code. Second, inherited vulnerability. The AI reproduces insecure code that it learned from us. And third, active exploitation, where attackers can deliberately trick the AI into creating malicious content for them.
And hey, don't just take my word for it. This quote, it comes directly from the AI's own documentation. It says, and I'm quoting here, "Use Copilot together with testing practices and security tools as well as your own judgment. Even the people who built it are telling you, straight up, that this is a powerful tool, but it is absolutely not infallible. It needs you. It requires human oversight."
Which really brings us to the final, most important question. These tools are called copilots, right? They're assistants, supposed to be there to help you on your journey. But after everything we've seen, all these hidden risks, you really have to ask yourself, are you still the one flying the plane? Are you the one in the pilot seat, making the critical decisions, staying alert at the controls, or have you fallen asleep at the keyboard?